Here's problem 1120. Two objects mass m1 equal to 2m, m2 equal to m, move around rotation axis O in parallel circles of radius r1 equal to r, r2 equal to 2r, with equal tangential speeds. As they rotate, forces of equal magnitude are applied opposite to their velocities to stop them. Which statement is correct? So we have mass 1, m1, which is this one, and m2, which is this one, and m1 has a moment arm r, and m2 has a moment arm, that's called r1, and then r2, r2 being twice as long as r1. They both have the same force working against them, and they both have the same initial tangential velocity in the forward direction. So if we were to consider mass m1, which is equal to 2m, then we would say that our net torque is equal to moment of inertia 1 times angular acceleration 1 by Newton's second law, and that should equal our force F times moment arm r1. Sounds good? Moment of inertia for a point mass would be m1 r1 squared for this point mass times angular acceleration alpha 1, and that will equal F times r1. One of the r1s will cancel out, and so we have, and m1 is equal to 2m, so we have 2m, r1 is equal to r, so that's r times alpha 1 equals F, or alpha 1 is equal to F divided by 2mr. Sounds good. For m2, which is equal to m, if I can get this to right, we have our net torque, this is a torque here, is equal to moment of inertia, I2 times alpha 2, and that is equal to F times R2. And we have mass 2, R2 squared, times alpha 2 is equal to F times R2. One of these R2s cancel out, and m2, which is equal to m, r2 is equal to 2r times alpha 2 equals F. So alpha 2 is equal to that same F divided by 2mr. So the angular accelerations applied to both masses are the same. Alpha 1 equals alpha 2. Good to know. But we're not done yet, because our initial angular velocities are not the same. Our initial angular velocity for mass 1, omega 1 naught, is equal to our velocity v divided by r1, which would be equal to v divided by r. And our initial angular velocity, omega 2 naught, will be the same linear velocity v divided by r2. But r2 is equal to 2r, so this is v divided by 2r. So omega 1 naught is equal to 2 times omega 2 naught. In other words, omega 1 naught is greater than our initial angular velocity for particle 2. So they have the same angular acceleration, alpha 1 equal to alpha 2, but omega 1 naught is greater than omega 2 naught. Hence it's going to be hard to stop, since we know in general that our final angular velocity is going to equal our initial angular velocity plus angular acceleration times time if our initial angular velocity is greater and they have the same angular acceleration in both cases, then it's going to take more time to stop it. So it'll take twice as long to stop mass m1 as it does to stop mass m2. So that means M2 will stop first. So we have a greater torque on mass 2. However, it turns out to be the same angular acceleration. We have a lesser angular velocity to begin with, hence mass 2 will stop first. And in terms of our options, that would be answer C, I guess, as the best option for an answer.